Welcome to my channel. In today's topic, we'll be dealing on chemical equilibrium. So what is a chemical equilibrium? We define chemical equilibrium as the transformation or change in composition of the reactant to give the product, and in turn, there is a change of the product to give the reactant. So in our previous lesson, I discussed what is known as chemical equation. Let's use hypothetical values to explain this. Plus B to give C plus D. We said there's a change in composition of the reactant to give birth to the product. In turn, there is a reconversion of this product to give the what? The reactant. In this sense, there's a reversible reaction. There's a reversible reaction. That is to say, any system that is in equilibrium must be in a reversible state. In a reversible state. That is one of the conditions. Reversible state. So, it must be in what? A saturated solution also give a system that is in equilibrium. So, to say, we can explain this chemical equilibrium in a very concise way using a seesaw. A seesaw that contains two body weight. Let's say we have a pivot here that contains two body weight, 50 kg and 50 kg. In this kind of seesaw, you notice that the seesaw will be balanced with this pivot because both weight they are the same. If peradventure there is a 60 kg here, there is a 40 kg here, the seesaw will move to the side to balance this weight. Just to balance this weight, the seesaw will move to this direction so that the effect of this weight change will not be felt. So, in this aspect, we can use, as a lover of soccer, let's use football formation. For instance, in football formation, your team is using 4-4-2 for instance, and one of these striker here is red carded. You notice that the coach will change strategy in this formation so that the effect of this guy that is red carded will not be fed by other players. So the formation can actually drop, or they can rearrange yourself to counter the effect of the guy that is red carded. So in this aspect, this brings us to the man that discussed this term chemical equilibrium known as Chatelier. And he gave us a principle known as Chatelier principle. This principle states that if there's an external constraint or there's a change in a factor such as pressure, temperature, and concentration in a system that is in equilibrium, if one of them is altered, they said the equilibrium position is going to adjust so that the effect of whatever that change will not have effect on the system. That is to say, if this pressure, there's a change in pressure, there is a what? The equilibrium position is going to adjust or shift so that the effect of this pressure change will not have effect on the system. So in this aspect, we are going to discuss what are the factors that affect chemical equilibrium. Factors that affect chemical equilibrium, factors that affect chemical equilibrium. We said one, we have pressure. We have two, we have temperature. We have three, we have concentration. But in this video, we are going to focus more on this pressure, effect of pressure. So for pressure to have effect on a system that is in equilibrium, there are conditions in which the system will meet. Said the reacting particle must be in a gaseous form. For instance, now let's use this equation. Let's use for ABBA process as a very good example. It's a very good example to illustrate this effect of pressure on chemical equilibrium. We said one of the species, one of the participating reactant or the product must be in a gaseous form. And what is a gaseous form? This small g that is written below this chemical symbol means that this species is in a gaseous form. We said one of the species must be in a gaseous form. And if you check the theory of the species that is present now, they are in gaseous form. The other one, we said the mole ratio of the reactant and of the product must not be the same. In this aspect, for us to have the mole ratio of this equation, we must balance this equation. We must balance this equation. We said we have two nitrogen here, we have 6 hydrogen. To balance this equation, to make this hydrogen gas to be 6, we're going to add 3 to this hydrogen gas. That is to say, according to this equation, we have 1 mole, 1 volume of this, or mole, plus 3 volume of this to give 2 volume of ammonia. 2 volume of ammonia. What this means is that we have 1 plus 3 to give us 4. It produces what? 2 mole, 2 volume of ammonia. In this case, the first condition is met that the species of the reactant and of the product must not be the same. The second criteria is that the mole ratio of the reactant and of the product must not be the same. In this case, what is the effect of pressure in this kind of equation? Where would the equilibrium be moved? Where will the equilibrium move to? Is it to the left or to the right when the pressure is increased or decreased? So we're going to make use of 2 laws. We're going to make use of 2 laws to explain this concept. We're going to use Boyle's law and Avogadro's law. And before now, we already know what is known as Boyle's law. Boyle's law spoke about 2 parameters, pressure and volume. And according to Boyle's law, we said the pressure of a given mass of gas is inversely proportional. What we mean by inversely proportional? The pressure of a given mass of gas is inversely proportional to what? To V. That is to say, as pressure is increasing, volume is decreasing. That is to say, as pressure is increasing, volume is what? Decreasing. So this is what we have. We said P1, here will be what? Will be V1. So as this one is increasing, this one is decreasing. In this aspect, we say if pressure is increasing, volume is decreasing. We say in the other one, I'm going to talk about Avogadro's law. Avogadro's law. According to Avogadro's law, it says equal volume of gases at the same temperature and pressure have the same number of molecules. That is to say, that is why the condition of mole ratio is very important, because according to Avogadro's law, if we have the same volume of the reactant and the product, there will not be change in the property of the product and the reactant, because they have the same number of molecules according to Avogadro's law. So in this now, when we use Boyle's law now, for instance now, the Boyle's law talk about 2 parameters I've said, volume and pressure and volume. As pressure is increasing, volume is decreasing. That is the meaning of inverse. That is the meaning of inverse. So what happened in this kind of reaction? So for instance now, you are working in a company that used to produce ammonia, and you are a chemical engineer. You are asked to produce ammonia in excess that the company from Port Harcourt needs 30 tons of ammonia. So you are in the company, you are asked to produce this ammonia. What will you do in this kind of reaction? Are you going to increase the pressure, or you're going to decrease? So we're going to make use of Boyle's law to explain this concept. For instance, now, let increase in pressure. If pressure is increasing, volume is decreasing. That is the meaning of inverse. Increase in pressure, this is P, this is V. Increase in pressure, decrease in volume. For instance, now, you're going to look at the side that is having the lower volume. You're going to look at the side that is having the lower volume, because we said increase in pressure, P, what? Increase in pressure, decrease the volume. So look at this side. We have 4 volume here. We have 2 volume at the product side. So increase in pressure, the equilibrium position is going to look at the side that having the lower volume. The equilibrium position is going to look for the side that is having the lower volume. In this case, increase in pressure, the lower volume is at the product side. So equilibrium position is going to move to the right. Or the equilibrium position is going to adjust to the right because it has the lower volume. So equilibrium position will move or will adjust, will move to the right, favoring the product because it has the lower volume. This is increase in pressure. Increase in what? In pressure. So what will happen when this pressure is decreased? Where will the equilibrium position move to? So we are going to talk about decrease in pressure. That is to say, if pressure is decreasing, this is P, volume is what? Increasing. Pressure is decreasing, volume is what? Increasing. That is to say, if pressure is decreasing, volume is increasing, volume is going to look for the side. The equilibrium position is going to look for the side that is having the lower volume, the higher volume, pardon. Because we said decrease in pressure. Equilibrium position is going to move to the side that's having the higher volume. If you check these two volume, the highest one is what? Is the volume, is this reactant. So equilibrium position will move or adjust, move to the left, favoring the reactant. So this is all we have been able to do today. In this aspect, we'll talk about chemical equilibrium, we'll talk about the factors that make a system to be in equilibrium, we'll talk about the effect, we'll talk about the Chatelier principle, we'll talk about the effect of pressure on chemical system. So we talk about Boyle's laws and Avogadro's law, the effect of those laws on chemical equilibrium. So this is the end of the lesson. Thank you for watching. Please subscribe to my channel for new videos. Thank you.